that if you go to this main website here, and so the Canvas page, and scroll down, I've put the links to the video captures that we've done each of the days. So if you happen to miss a day and you want to go check it out, you can. It'll give you an idea of about which range of questions that we went through. If you want to look at any video captures of other types or the other questions that we didn't go through, if you scroll down to where this content area box is, I've put the video captures for all of the questions. So like all of the questions from the algebra content, 1 through 35, are located here. All of them, odds and evens, for the Algebra 2 concepts are located here. This weekend, I will finish these last two sections, so that I'll try to get them done if I can today or tomorrow. I know if you're taking the test itself this weekend, that might be too late. But if you have any questions, use the message system on My Open Math. Ask me. And also, if you access this right here, the questions from the notes, for most of these, I already have video captures embedded in the questions themselves. And so you could possibly see the explanation there. And most of them have detailed solutions where you can click on it and it'll explain that process. It just might not go through the Desmos solution without the video. The Desmos solution is usually just in the video. All right, so that's where those will be located for you to look at and refer to. These, and using the discriminant, you don't really think of the radical being there. I mean, it's not really going to affect anything, because when you square both sides, the radical disappears and the 0 stays a 0. So if you compare this to what I had on the previous slide where I didn't write the radicals, this is probably like preferred, like not writing the radicals. You don't need to think of these as being radicals here. So on a problem like this, again, I'll show you a couple different ways. Okay? But if you're solving this mathematically, like the way that the SAT is trying to test, is that you would expand this out. So distribute your x. That gives you kx squared minus 36x is equal to negative 36. And now you have this quadratic function, quadratic equation. So we're going to move everything to one side and set it equal to 0. So add 36 to both sides. And when you do that, what you wind up being able to do is now to see. It's asking you, or telling you, there's no real solution. No real solution means that the discriminant is going to be negative. And so if we set up a negative discriminant here, so if we say b squared minus 4ac is negative, less than 0. So here's our b value, negative 36 squared minus 4 times our a value is our unknown k, and our c value is 36, and that whole thing is less than 0. And so what I'm going to do here is, I'll calculate it out. So negative 36 squared is the same as 36 squared, so 1296 minus 36 times 4, is 144, so minus 144k is less than 0. If we add 144k to both sides and then divide by 144, we get our answer. K has to be greater than, and if we took 1296 divided by 144, we get 9. So we're told that k is an integer. So what's an integer? What's the first integer that is greater than 9? 10. There's your answer. Okay. Now, did anybody do the visual solution on the graphing calculator? Okay. All right. So the other way that you could solve this here would be to just type the equation as it appears. So leave k as part of your expression, and give k some value to start with. So I'm going to call it k equals 1. And so notice what we're looking for here is no real solution. That means, like right here, this is our solution. The solution is this intersection, 1.029. But we want to find a place where there is no solution here. Actually, let me zoom out so you can see it. And this second one of 9.796. So as you slide these, the no solution means that that's going to disappear. Notice right here, once it gets past 9, it disappears. There is no more solution. And again, you can zoom out and see that that's the case. Okay, and so you would take the first integer after this. So the only integer, the first integer you get to would be your 10, and that would be the correct answer. So you can solve that with a little more visual process. All right, try the next part of this, the second part to this question. See if you can answer that form, please. So once again, I'm going to talk through the mathematical way to solve it first. Then I'm going to show you the visual way, because the visual way, especially when you have answer choices that you can test. So like when we create the slider for this problem, we only need to test 5, 15, 30, negative 35. Those are the only values we test. One of them will work. And so if you have answer choices to plug in on a slider, definitely, like I encourage you to try it visually, or be comfortable working with it visually. But if we're solving this by hand, what we're looking at here is we're told which of the equations will have more than one real solution. So that one now is, we will set the discriminant greater than 0. So if we take our, we have it already written in that form, so b squared minus 4ac set greater than 0. Our b value is unknown, so it stays our variable, times 4 times our a value is 9, and our c value is 25. That's all greater than 0. And so if I multiply those through, 4 times 9 times 25, I get b squared minus 900 is greater than 0. Now, one of the reasons why I kind of wanted to talk about this is working with solving polynomial inequalities is sometimes, like, again, it's not anything that's like taught early on. And so like it's very specifically taught at one point in time, maybe in Algebra 2, maybe in pre-calc. And so the way that I teach setting this up, this isn't one where you just add the 900 square root both sides, because you have to account for positive and negative roots. And so the way that you tend to solve this is you factor your polynomial. And so b squared minus 900, that's the difference of two squares, right? b plus 30 times b minus 30. And so if you've been taught this, or again, like the way that I would teach it, is you then set up a number line with your critical points. So our critical points are negative 30 and 30. And you're going to evaluate what happens in those intervals. Now, your teacher might have you just plug in points for b and then test different things. And so here, what I would do is set my two different factors separately on separate lines. And then what I'm going to do is I'm going to evaluate. So here on this line, any number that's to the left of negative 30 is going to give me a negative value, correct? Any number that's greater than 30, negative 30, when I plug it into this factor, is going to give me a positive. When I test my b minus 30, any number to the left of 30 is going to be a negative number, and any number to the right is going to be a positive. And so that's what I would test. And then if you take the overall products, we get a positive in this interval, a negative in this interval, and a positive in this interval. We want all the intervals that give us greater than 0. So we want the positive intervals. So our intervals are going to be everything to the left of negative 30 and everything to the right of positive 30. So 5 falls somewhere in here, not in the right interval. Negative 35 falls right here. That is in one of the correct intervals. 15 falls somewhere around here, not in the correct one. 35 falls right on that, on the critical point, but again, it's not a greater than or equal to, it's greater than, so that would be 0. That wouldn't work either. So the only one that works here is our answer choice, negative 35. Okay, now visually, or if you solve this just by typing your answer in, Okay, so notice I didn't, for this, I didn't set it equal to 0 here, although you could. But what I want to do is I want to test these values of b here. So I want to look at the graph of it. I don't want the solution, I want the graph. And so I want to find where there's more than one real solution. So which of these 4 possibilities for b gives me a graph that intersects the x-axis at 2 places, right? That's more than one. So if I test 5, notice 5 doesn't even intersect, so that's not it. Negative 35 intersects at 2 places. So I know that's my answer right here, but I can go ahead and check the other ones just to verify. 15 doesn't intersect at all, or sorry, 15 doesn't intersect at all, and then finally 30. 30, it does intersect, but it intersects just at this one point. So visually, you can test this really easily also. I strongly encourage you, get familiar with Desmos. It will be a huge benefit to you on the test. Okay. I want to show you how to use the calculator to do mean, median, the central tendency statistical pieces of information, because it will do that. And so I'm just going to talk you through a lot of them today. So looking at this one right here. So this is, bless you, this is considered like a very challenging question. However, if you understand how Desmos works, Desmos can give you the mean and the median of a set of numbers. And so what we can do with this is we can actually just take this whole set of numbers. Now notice it also says that you're adding one more. So this is 9. What's the value? Or if you take, if the mean of this is this whole set here is greater than 7, if you add one more value, okay, then it's asking what would the what's the smallest or what's the largest value going to be from this if you have a set of numbers that are 10 positive integers that are less than 53. Okay, so A represents that 10th one. And so what we can do is we can just enter this in a table, add plus, the little plus symbol table, and just put it all in one column. So if we just list everything in one column, and notice I'm going to list my 10th one as A, some unknown. This is it needs to be an integer, right, based on what the question is saying. Anytime you access an unknown, if it doesn't prompt you for a slider, just create it yourself. Just set A equal to some number. I'm going to call it 1. I mean, it can be anything, but I'm just going to give it the value 1. Okay, and then the next thing you do is it asks you for the mean. You want to know what the mean is. So you just type the word mean. It's also located in this drop down, or in the keyboard. If you go under functions and scroll down, look under statistics, you can kind of see all the different statistics that you can identify using this calculator. But here it's just the mean. And then in parentheses, put the column number. The name of the column was X1. And so when you close that off, right now, if A is 1, your mean is 33. But this is saying we want a mean that is greater than 37. So what we can do is slide our slider. We see to the left it makes it smaller, to the right it makes it bigger. Hey, the 10, it's still not an integer greater than 37, right? Which means it needs to be to 38. So if we click on that 10, let's make a larger range for our slider. And so we just keep sliding until we get to, remember, we have to get to 38, an integer that's greater than, right there. Now I have an integer that's greater than 37. Again, not a decimal, but an integer. That's my answer, 47. So it takes this really hard problem. I mean, again, if you read through the explanation, and it's probably on the video capture or the detailed solutions as well, the handheld, or the solving by hand calculation for this is somewhat complex to understand for a lot of students. If you use the slider, super easy. Okay, so again, be familiar with what you can do with this. Okay, so try the next problem, 79 on your own. Just really quickly see if you can find the mean of that list. Just make sure you can do these calculations. If you're familiar with Desmos, there is an additional way that you can enter lists on Desmos, but to me, just staying consistent with using the table is nice and easy. So again, access the plus, add the table, just list your terms. The only thing to make sure is that you are copying these down correctly. Okay, type mean, access the column that you're using. The mean for this is x1, is the column name, and so I get my total average of 8. Now again, you could add these together, divide by the number of them, the total sum would be 80, divide by 10 gives you 8 as well, but just entering it in, not having to worry about it, is a nice, again, useful way to use the resources they give you. Okay. All right. As you scroll through these, the next content areas here, this is all in that, the section that we're looking at here is, you can see here, problem solving and data analysis. So it's kind of like dealing with proportions and probabilities and percentages, as well as kind of interpreting some of the tables of graphs and using stats. Hey, most of these are things that are relatively straightforward. These statistical claim stuff is, like, again, they're generally harder questions. Most of them are kind of intuitive, though. There's not, if you don't quite get it, give it your best guess. They're mostly intuitive. The one main thing to think about is if they ask you some kind of a claim, the pool, whatever your sample pool is, the claim that's made only applies to that specific sample pool. Okay, so like this question here where it says, English professors selected at random from Vermont State University. That means that whatever claim is made on this is only applicable to English professors at Vermont State University. It's not applicable to a broad range of different things. Okay, and so that's like the main, and like I said, it tends to be somewhat intuitive for that. So I'm not going to go through that. What I do want to talk through, though, is how the SAT kind of tends to approach right triangles. So I want you to try 99 really quickly. See how would you solve that question. Okay, they do expect you to understand trig ratios, but really the limit of the trig ratios that you need to understand is how angles match up in similar triangles based on the SOHCAHTOA relationship, sine, cosine, and tangent, okay, or to just be able to find that the sine tangent or the sine cosine or tangent. Okay, it's not going to ask you to do like a really detailed or complex calculation with them. The most of what you'll see is it'll tell you you have similar triangles. The sine of one angle is such and such. Can you find what the sine or cosine of the corresponding angle in the similar triangle would be? Okay. All right, as a reminder again, SOHCAHTOA is the acronym used to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, and so if you just sketch what you have right here, triangle RST, where it says the measures of angle R and S adds up to 90 degrees. So that means R and S are your acute angles, leaving T to be the right angle. And if it tells you that the sine of R is some given ratio, so sine is so, opposite over hypotenuse. So with respect to R, the opposite has to be the root 6, and the hypotenuse has to be the 20. And so here, it's possible you need to know what the other leg is to solve this, but it may not be, because if you look at the question here, it asks, what's the cosine of S? Well, cosine is adjacent over hypotenuse. So with regard to S, we have an adjacent leg and hypotenuse. Those are the values that are already provided. Okay? So if this is the case here, you simply rewrite root 6 over 20. Now, it is possible if they ask you what's the sine of S or what's the cosine of R, then you would have to use Pythagorean theorem to calculate the remaining side. But again, just read through the question to determine what exactly it's asking you. Right. The next thing, again, to be aware of that is covered on the SAT potentially, and that is the equation of a circle. And again, not everybody is as familiar with that. So make sure if you are not that you kind of review. But this right here is the equation for a circle, where h and k are the coordinates of your vertex. The r value is the radius of that circle. And so I want you to kind of use that information here and just see if you can answer question 101, please. Looking at this information, you know that the h and k values have to be -7 and -3. Okay? So the first thing that you can do is you can take this standard form for a circle. You get x minus a negative h, so the minus a -7. So we get minus and minus is +7. Plus y minus k, k is -3, so y minus a -3 equals, and now you have your r squared value. So first of all, just by looking at this, you can eliminate some of the options, right? So it can't be this one, can't be this one. There is a little, I think I mentioned this, but there is a little box on the side where you can click, and you can give it, it will say something like, allow me to eliminate answer choices. So if you click that little button, it gives you boxes next to each, and when you X those boxes or check the boxes, it sort of like shades out those answers. So you can kind of do this and you won't be able to draw a line through your screen, but you can X out the boxes to hide those, the values that the options that you're canceling. So kind of right now you would likely see 10 versus 100, well, since this is an r squared value, it's going to be a perfect square more than likely. So again, you could probably kind of choose from this. If you are solving this by hand, though, the actual mathematical way to solve this is if you know that you have some r squared value, but you're not sure what it is, what you can do is you could plug in the given x and y coordinates. So when x is -1 and y is 5, you can solve for your r squared value. And so here you get 6 squared plus 8 squared equals r squared. 36 plus 64 equals r squared. And so notice you just replace the r squared with 100. You don't even need to go in and solve to see the radius is 10. 10 squared is the value that needs to go on the outside. So that would confirm that this option D, the last one, is your answer. Now you could also solve this by looking at it. If you typed in every single one of these equations on Desmos, and this would be sort of what you would do if you didn't know or didn't remember how to solve this problem. And so as you solve each of these here, now there is this little button where you can duplicate. If you click this little button, you can duplicate a problem. So if you want to duplicate this 4 times, it's this little settings, this gear icon, and then you can make your changes a little more easily. So -7 minus 3 is equal to 10, -7 minus 3 equals 100, and then this one, everything 100. Right, so if you take all of those and then you say my point -7, -3 needs to be the center of the circle. So right now I know I can eliminate these two here and here, right? So those two are eliminated. And then I also need to label the point, -1, 5. And now you can see the only circle for which that's that center and the point on the circle lies is that, and it highlights the correct answer, which if you go into scroll through, is the one that, again, we solved for. Okay, so you can solve these visually as well if you just take the time to type in the equations. Okay, I want you to try question 102 also. See if you can answer that using that same process, please. Solving this mathematically, you would do it by completing the square. Okay, and so if that's the process you use, what you would look to do is group your x terms together, kind of leave a space to complete the square. Group your y terms together, leave a space to complete the square. And then you have your constant over on the other side, which it's already there. Okay, and so if this is the process, completing the square for each of these variables, we take half of our first degree terms coefficient, so half of +1 is 1/2, so +1/2. We square that value and add it to both sides, so 1/2 squared is 1 squared over 2 squared, so we add 1/4 to balance this equation. The whole point of completing the square right here is it allows us to rewrite this quantity as a binomial square. And the binomial will always be a first term of x, and a second term is half of that first degree term's coefficient. So again, half of +1, and that's why I write it in parentheses and I put the sign of it in there too. So this is my +1/2. And then the y values, I complete the square, take half of my first degree term's coefficient, which is also 1/2. Square it, add it to both sides. And so when I add 1/4 and 1/4, that gives me 2/4, or 1/2. 1/2 plus 161 halves gives me 162 halves, which is 81. Now, I can rewrite my binomial square here as y and then +1/2, although this winds up being irrelevant to the problem, like as the answer. But when I take my 81, 81 is equivalent to r squared, which means my radius is 9. And so that would be my answer. Now, what if I entered this whole equation directly in the calculator? When you look at this equation here, so notice the center is not 0, 0, right? And it doesn't pass directly through the 10 and the -10 here. Okay, but if you were to find these intersections, so notice here's an intersection of -9 point, or I'll kind of write this out. So I have one diameter passes through -9.486. Now, obviously, these will likely be approximations here. The other x-intercept is 8.486. And if I want to find the distance between these, if you do recall, mathematically speaking, the distance is the absolute value of the difference of their coordinates. Okay, so if I go in here and I use the absolute value of the difference of those coordinates, so -9.486 minus 8.486, like I said, it's an approximation, right? We are using equivalent. So you can see that this would be approximately 18. Cut that in half since that's a diameter, and that would confirm that 9 makes sense for your answer. Okay. All right. The last thing that you are kind of expected to know that's not always the most common, or it's relatively new, is the SAT will potentially ask you to convert between radians and degrees, or do some work where you're combining them. So I want you to try question 103. See if you can answer that question before I talk through it. Here are the notes for radians. Okay, the conversion factor for radians is pi radians is equivalent to 180 degrees, or 2 pi radians is equivalent to 360 degrees. And they may talk about arc lengths as well. Keep in mind that an arc length is some fraction of a circle's circumference. So that fraction m over 360 times any circumference calculation. So it could just be a given circumference, could be 2 pi r, could be d pi. Those are the various circumferences. So for a problem like this, what you're going to do is you're going to take the 2 radian measures they give you. Okay? It asks you if angle t is 12 or 7/12 pi radians greater, what we're going to do is we're going to take 2 pi over 3. We're going to add 7 pi over 12, and that's going to be the measure of angle t. And so if you calculate this here, convert the 2/3 into, or again, if you're doing this by hand, which you don't have to, we'll come back to that in a second, but if you're doing this by hand, you would convert this into the same denominator, right? So if you multiplied this first fraction's denominator by 4, you'd get the same denominator, 12. So 4 over 4 has a value of 1. Identity property doesn't change its value, just the form. So 8/12 pi is equivalent to 2/3 pi over 7/12 pi. So when you combine these, 8 and 7 is 15/12 pi. Convert in to radians, or from radians to degrees. Pi radians is equivalent to 180 degrees, and so again, the pi cancels, and your calculation, 15/12 times 180, and so the answer would be 225. Okay, now, you don't necessarily even have to do this part by hand, right? If you just take your calculation here, 2/3. Now, you don't need to write the pi units in there. We're just looking to combine those fractions. So plus 7/12. Click this fraction key, and you see what it reduces to. So your angle t would be 5 pi over 4. Convert this, 180 over pi. The pi's cancel, and so what you would then take times 180, and that would be your answer as well.